I then like to pop across to issues. And if you recall, we categorize issues by data, posture, and runtime. So an example of posture, we can see that there's broken verification of expired tokens. We can see there's data, forbidden data in responses. So once again, this is all sort of hygiene and configuration and development that you can go and fix right now to help improve your security. The second, and I think more interesting aspect, is when we start moving into runtime protection. So at this stage, our unsupervised ML has built out behavioral-based, what's good behavior for an API. And we can start picking up when there's anomalous behavior around that. So a good example is broken object level authorization, which is the number one OWASP, the number one in the OWASP API top 10. And in this instance, we can click on it. It provides us a description that a user has suspiciously attempted to access multiple API resources and has successfully accessed 9, while typically the user only accesses 1. Right? So high severity, it's mapped through to the OWASP API number 1, as I mentioned. Here's the API information, where we captured it, and the identifier of the individual. So we've identified, in this instance, it's Francis, and we've identified him by a JOT token, and we've also identified him by source IP address. Right? So if we go and look at the evidence, let's look at what's happening under the hood here. Our platform has worked out that there's a correlation between the path and the user ID. So as you see, it ends in 4011, 4011. So in this instance, Francis has come into the platform, his user ID and the path have matched, he's successfully authenticated, he's got his token, and he's successfully retrieved his information, Francis. What we then pick up in is Francis has come back in, so it's still Francis, he's still using the same user ID, but he's manipulated the path parameter. So you can see now that no longer matches with 4011, so it's broken that correlation. And that's what's deemed as suspicious. And he's actually now exfiltrated Noah's information and Alexander's and other Sebastian's, etc., as it goes on. And this is really the powerful aspect of that, the AI ML helping with runtime. And it's the sort of behaviors that, a WAF and a API gateway wouldn't be able to pick up on. So directly within the platform, we can take action. The action can be sending an alert to Splunk, sending something to Slack or to Jira. We can also move across to the attackers, and you can see Francis here. We can actually block the intruder. Again, leveraging those prevention integrations we showed earlier. So with an Apogee, we can block them at the token level, or at one of the infrastructure components, we can block them at the IP level. Right? Now, of course, everything I'm showing you here is clicking, but you can build out policies that can semi and fully automate this, as well as integrating in with your existing workflows. So we can take that preventive action and send an alert to Splunk. So your SOC operators don't need to come and jump into this platform to have a look at what's going on. We can push that out to them. So very extensible via syslog and webhook itself. All right. I want to pop back to issues again, because what you would have hopefully spotted is an element of obfuscation. So typically our platform ingests all the traffic, analyzes the memory. If there's nothing interesting, discards all the payload packet and just retains the metadata. The exception is when there's a posture or runtime issue and we capture it for evidence for your forensics team. But even in this instance, credit card being a sensitive data type,